In this video, we will cover the review exercise 1 at the end of tutorial 1 on pages 90 through 94 in the text. I highly recommend that you first take a little time to look over the drawing and read the instructions that follow, as these are the guidelines I will use to grade the assignment. We first look at our drawing, and we are instructed on page 91 to create the wireframe in 2D. So we'll start with the rectangular shapes. We go to our Create Rectangle shortcut, enter the dimensions of 5 inches. These are already in there because I practiced. Make sure that our anchor to center is activated, and you'll see we'll snap to center, but we won't really see the rectangle because it's so large. So I just simply roll my mouse wheel toward myself, and there we can see the whole thing. You could also just hit Fit. We're working in the top view. I'm going to apply that and make another one that's 4 inches. Hit enter to get my phantom rectangle and snap that one to center. We can just say OK to all that. We have fillets on this interior rectangle to put in. I'm going to go to the fillet shortcut and open up the list to fillet chains. I'm going to select this chain. Direction doesn't matter for this. That's more for when you're cutting. I'm going to say yes, I want that chain, and it puts some fillets in, but they're the wrong size. Since we haven't applied anything or said OK, we're still active. So I can go change my radius to 1 inch, hit enter, take a look at it, and that looks good. So I'm going to say OK and basically check out of the command as opposed to just applying it. We have a circle at a diameter of 0.825. Create circle center point. Diameter of 0.825. If we hit enter, we can get the phantom, and now we just snap that to center. We're just going to place it on the 0 in the Z this time and move it later. There's so many different ways to do everything here. That's why we do things different ways to do the same operation. They want to show you the many ways. I'm going to check out of that command. See everything here. If I just push down on my mouse wheel and move the mouse itself, it shows me that everything's on the 0, 0, 0 in the Z axis. Back to top view. Now we need to copy a few things. We're going to first, you can go to Xform, translate. Now it says to select entities to translate. I need to select all these separately as entities, all 8 of them, because if I just boxed it, I would pick up my circle, and I don't want my circle to be in the same place. So I can click enter or end selection. We're going to move we're going to copy this. We're going to make 2 of these. It's going to be -75 in the Z-axis. We'll accept that. I'm going to push my mouse wheel down and just have a look. Looks good. Go back to my top view and reset that. Now I'm still in the command. Select entities to translate. I want to translate this one. End selection or enter. This circle, we just want to move it. We don't want to make a copy. And we're doing this in lieu of having placed it in the Z-axis initially. Say we forgot or something. This one will go down to -0.25. I'm assuming that our print is giving us the top of the boss in making this decision. It's not clear on the print. This is where you'd have to call up the engineer and ask them what they're referring to, because on the print we can see the fillet around the boss and it looks, I can't tell, I can't see the draft, so I'm just going to presume that it's the top of the boss at 0.825. And click OK. Looks like it disappeared, but if you just roll your mouse wheel, everything will fix itself. I'm going to push down and pivot again to make sure that's what I want, and it is. So I'm going to go to the isometric view now. So here we actually copied the geometry instead of drafting it down and then putting all of those edges on them. This is just another way of doing this. But we didn't do that on the circle because it's going to be at an angle, and so we don't really know what the bottom diameter is going to be. So in that case, we'll go ahead and draft it first and then put the edge on, like we did on the first one. So we're doing things a little differently on the student exercise, just for learning purposes. So now we're instructed to create the draft surfaces. It's a good time to change colors. We change the color. Now I'm going to go up to create surfaces. Surface is going to be a large part of everything we do in this course, 3D course. I'm going to go down to draft. Now it says to select a line, arc, or spline. Basically going to pick this whole chain. See, it lit up the whole chain. Yes. Okay, I want that chain. So it's in the wrong direction, it's the wrong size. We can fix all of that. This will toggle different scenarios that you may want. One direction, both directions, either or. So that's the direction I want, but my distance is 0.75, and we don't use negatives here because of the fact that we can go in all directions. There is no angle on this. So when I hit enter on the 0.75, it'll change it. Now I can accept that. I want to stay within the command though. Select another chain. I'm going to pick the top of this boss. OK. It's too big. This one, since we set it down at 0.25, we only need to go an additional 50 to reach the bottom of our dish. And I can go ahead and enter that. Looks like it's going the right direction, so I don't need to flip it. And we put the angle on it of 10 degrees, hit enter. Okay, and our draft is going in the opposite direction of what we actually want, so I just hit the flip button. It looks good. Say OK and check out of that command. Next, we're instructed to create the edge curve on the edge of the draft surfaces. We have two draft surfaces, but this one's actually got geometry around it at the bottom, so it's got an edge. We just need an edge for this boss. Our geometry is at the top, but we don't have an edge at the bottom, and we're going to need that to put our flat surfaces in so we have something to select in terms of a boundary. So I go up to create, curve on one edge. I might want to wheel a little closer to this. Just wheel the wheel away from yourself. It says select a surface. I'm going to select this surface. Move the arrow to the desired edge of surface. I have geometry at the top. I need my edge down here, and I am not pushing any buttons. Once I click the surface, I just free mouse down and then click. And now it's selected. And I can go ahead and check out of that command because I don't need any more edges. So now I can go ahead and create my flat surfaces as instructed. You can mouse wheel this away from yourself. If you hit the alternate button and depress the mouse, you can slide it. Take off the alternate button and press the mouse wheel. It will pivot. You're going to get used to moving this stuff around a lot because you're going to need to in 3D. You want to get straightened back out, just hit isometric or whichever view you prefer and fit. So now on page 92, create flat boundary surfaces. It says to create 3 of them. I'm going to change color again. We'll go to the green. OK. Back up to Create, Surface, down here to Flat Boundary. Now it says select Change to define flat boundary. So we don't need to hit Enter in between these chains. We can just click the first one and the second one. Preferably they need to be in the same direction, so we'll reverse that one. Select OK, and it popped the flat boundary in. I'm going to apply that because I still have 2 more to do, so I want to stay in the command. Now I want to select this chain and this newly formed edge we created earlier. Select OK. Boundary looks good. I want to apply it. Now select Chain to define flat boundary again. There's that one. That's all I need. OK. And we can select OK to get out of the command. And there's our flat boundaries. I'm just depressing the middle mouse wheel and pivoting this all around. To slide it, you put the alternate key down and do that. So we can isometric fit again. Next we are instructed to create the fillet surfaces. Create, Surface, Fillet, 2 surfaces. We're going to do 4 of these, so we're going to stay in this command. We're first instructed to select a set of surfaces and then press Enter. I'm going to start with the boss. Here we need to press Enter between each surface set selection. It's kind of confusing. This whole operation can be. I had a lot of trouble with this fillet command. So we select our first surface or set of surfaces. In this case it's just 1. Don't forget to hit Enter. Now we're instructed to select our second set of surfaces, which would be this one. We only have 1. It changed color, so we hit Enter again. Now we get the form to fill out. The radius on this fillet is 50 thousandths. Enter. Select Trim, Join, and the Auto Preview. It looks like it put it in correctly, so I'm going to apply that. Ready to do the next one? Select the first set of surfaces and press Enter. I tend to pick the flats first, just so that I have a standard operating procedure when I have to go back and debug, in case order of operations comes in. That's my first set of surfaces. There's only 1. I hit Enter. Select the second set of surfaces. There's only 1. I hit Enter. My auto preview and everything is already activated, and it looks okay other than the fact that I need to change the radius size, which it's 0.1 according to our drawing. Enter, and that one looks good as well. Apply it. Now we're going to do the ones in the bottom of the deep well and the top of the deep well. Up here it says select the first set of surfaces. I'm going to pick the flat first. That's only 1 selection for that whole set. Enter. Select the second set of surfaces. That will be all of these. There's 8 of them. 1, 2, 3, 4, 5. Depress your middle mouse wheel, flip it a little bit, press the alternate key, your middle mouse wheel, and you can slide it up. 5, 6, 7, I'm sorry, that's 8. They're all lit up, so I can press Enter, go back to my isometric view, and that looks good, except for the fact that my radius size is incorrect. This one is 1/4 of an inch, 0.25. Hit Enter, and it generated that radius just fine. Last one is up here on this edge. We want to radius this top edge according to our drawing. It's 0.375. So we'll apply the 1/4 inch one. Go back to the command. It says select the first set of surfaces. I'm going to pick my first set of surfaces. Six, 7, 8. Enter. And then try my flat lastly just to see what happens. Second set of surfaces, enter. See, it acts up. It may have acted up anyway. So we're going to learn this major workaround that's going to be a pain for a while. Okay, no fillets found. Let's reset our drawing. We need to go to Wireframe now. You can also hit, I believe, alternate S. Let's try it. Alternate S for solid, alternate S again for Wireframe. Middle mouse will bring your lines back. Just wheel. Okay. First thing we need to do is go to these options and make sure everything is checked correctly. Exactly like this. These 3 top of the lists and these 2 radio buttons here, they are correct. Click OK to that. We're going to try working here. Flip to normal. Gives you some arrows. It tells you which direction it's trying to create the radius fillet. My experience having practiced this part is that although it doesn't make sense, kind of seems counterintuitive, all of these arrows need to be pointing outward. You can click on the base of the arrow or even just the surface itself, as long as it lights up. When you hover on it, it lights up. Reverse these arrows. And then we need to, based on my experience, reverse this arrow as well, because it seems to me like down and out is what works. That's why I said it's counterintuitive, because doesn't it seem like this radius is going up and out? I'll go ahead and keep it and show you it won't work. Press enter when done. It still can't find a way to fill it. Okay. We'll activate these arrows again, and this time we're going to flip this one. This represents this surface out here. It really gives me fits when I try to click it. Sometimes you need to click the surface. Sometimes I need to try to click the surface itself in several places and move things around just to get it to take. It flipped. So we can press enter, and there it generated. So it wanted down and out. I'm not sure why. We go solid. Looks good. I'm going to check out of that command and do a fit. Lastly, we need to establish the stock. We're going to do this a little differently than we did in the tutorial. Here we're going to create a wireframe box using translate and join in the z-axis. Here's our shortcut to XForm translate. It says translate entities, which means I need to select these lines, not the surface, just the lines, those 4. I can enter or end selection, either one. We're going to use join. Last time I think we drafted it down. This is just another way of doing things. It says to go -1 inch, and there it is. So we can accept that. And now we've got some stock, and our picture looks exactly like page 92. So now we're ready to pick a machine and start cutting. Okay, so having saved your file, including your name and the assignment information in your file name, and picked your machine type mill, default mill, which is the only one we use for the Student Learning Edition, we'll then open up this tree, go to Tool Settings, set all of these boxes the exact way we've been doing all along in Mill Level 1, and then go to our stock setup. It's top, rectangular, we have a display on, and we are instructed on page 93 to establish the stock using the bounding box. So we click on that. It's selected everything. We want all entities and stock check, and from the 00 origin, which is right in the center here. So that looks good. And there's our stock. So now we're ready to do some cutting operations now that we've got a machine and some stock set up. We're instructed on page 93 to rough out the part using Surface Rough Pocket Toolpath. So we go to Toolpaths, Surface Rough, and Pocket. Say yes to this, or OK. Now we need to select our drive surfaces as we're instructed by the prompt. We can just do the quick mask, pick everything, end selection, or hit enter. We need a containment boundary. I'm going to pick the chain that goes around the entire part because I want to rough everything I can. And say OK, and say OK. Okay, we need a tool. So I need to go to the library, and it asks us to use the 1/2-inch bowl end mill with the 1/25 radius. So we'll pick that one. Okay. And here we're going to say to rough the part or the pocket. This verbiage is going to show up in your program dialog. So you want to say something that you're going to understand as it relates to your cutting operation, because you may have several cutting operations of Surface Rough Pocket Toolpath, and you need to know which one this is. So that looks good. We go to the next page in this form to fill out. Mill Level 1, we use these same parameters here in our linking toolpaths. We're instructed to leave 30 thousandths on this part. Everything else looks good. Rough parameters. Says leave a total tolerance of 0.01. Enter. And a step down of 0.1, so that's okay. To enable entry helix, I want to just change this to 50%. The rest of the defaults are good on that. Next, let's take care of that cut depth so we're not cutting air like we did in tutorial 1. We go to absolute. We want a minimum depth of -0.1 so that it doesn't cut around where there's nothing. Enter, and a maximum depth comes off the print, and that's a -0.75, and that will save some air time. So we got that taken care of. Now we go to pocket parameters. We're instructed to use true spiral with a step over percentage of 55% of the diameter of the cutter, which makes sense, 275. 50% would be 250 because we're using a 1/2-inch bowl end mill. And I think that looks good. It's been generated. We can backlot it. Fit and isometric. So make sure we're in the ballpark here. I can compress the middle mouse and pivot it around. It looks really good. We even started into some of that fillet because we used a containment boundary that included everything. If I would have used a containment boundary just of the pocket, it wouldn't have started into this fillet because it wouldn't be included. We can also verify it from here. And we can step it through just to see very little air where we're cutting. I can slow it down a little bit. It's kind of boring to watch it rough out a pocket, but spirals in, and we set that to 100 thousandths for depth. As you watch these, you'll start to see the context of some of those parameters we're filling in. We're not really sure what they are beyond the descriptions in the book. That's a place to start, but as you develop a solid foundation and a context with which to interpret this information, it'll all start to clarify for you. You can do alternate T, or sometimes you can middle mouse, alternate T. And we'll start the next operation. Page 93, it says finish the shallow areas using surface finish shallow toolpath, which is similar to what we did in tutorial 1. Pick a toolpath, surface finish, shallow. Now it says select drive surfaces. Here we're instructed to use the containment boundary of the pocket rectangle with the 1-inch fillet radiuses. But before I do that, I'm going to pick the entire job and mask the whole thing, and then go to containment boundary and pick this rectangle. I'm going to make it clockwise and check it. We're also instructed to pick a check boundary this time, which is the boss surface wall and selection, and keep that. And that's because we want to save some stock to use a more refined end mill later. I need a different tool for this. I need the 3/16 ball end mill. So here's my 3/16 ball end mill. I'm going to accept it, and I'm put some verbiage in of finishing the shallow. So that will show up in my program as well. Go to the surface parameters, standard here, standard retract, standard feed plane settings. We're not going to leave any stock on the drive surface, which is our machining surface, because this is a finished cut. However, we are going to leave some stock on that check surface in the boss there. We're going to leave 20 thousandths on that to finish that later with a more refined end mill. Now go to finish shallow parameters. The total tolerance is said to be 1,000. The maximum step over is 10. And the machining angle from slope angle 0, we're okay with that. And the 2 angle is 5. These are defined on page 79. And we're asked to enable order cuts by minimum distance. So that operation looks good. It still looks dirty because it's generating. You look over there, and there it is. I'm going to just use verify. Fit, isometric. I'm going to speed it up. Keep in mind the image that is on page 93 in terms of what we're supposed to look like upon completion of this operation. And it matches. So now we move on to page 94 for the final operation. Close this. And that is to finish the boss shape walls using Surface Finish Contour Toolpath. However, they don't mention that it also includes the large fillet, because that hasn't been finished yet. And it wouldn't do well using the finished shallow surfaces because it would try to machine this as well. So we do need to do it in contour with the boss. And that all comes into play when we're picking our containment chains and things. So we're going to go to Toolpath, Surface Finish, Contour. Again, we can mask the whole thing using the quick mask, or if you want to just roll it down a little bit and put a box around it by dragging your left mouse click button, you can do that too. End selection or enter. There's always several ways of doing everything in MasterCam. That's why sometimes it'll look like it contradicts itself, because it shows you one way and then it does it another way. You'll see that a lot between the tutorials and the student exercises. Our containment boundary in this case is going to be the whole exterior. We don't need to check the boss anymore. We just pick that and say OK and say OK. We do need another tool. We need the 16-inch ball end mill. And in our program, we want to write finish, boss, and fillet. Large fillet. It's all up to you what you want to put in there so that you know what's going on as your program moves along. Surface parameters, all of our standards remain intact. We are not leaving any stock this time, so that defaults perfectly. Our total tolerance, they're asking for 1,000 with a maximum step down of 10,000, so that's 0.01. They ask us to use a broken transition, and these are described on page 85. Cutting method one way, and enable optimize cut order. And check OK. I think at this point we should just select everything and verify. Fit and isometric. Slow it down a little bit and run it. Again, you can stop at any time. You can go to step through. Here is where you would go back to the beginning. And I'm going to let it run. I may stop it at times. We've already seen this operation verify, but I need the stock to be out of the way to see the finish cuts. I'm going to speed this operation up. You can see now we did this is the yellow one, is the roughing. This is the finish shallow, the blue one. And then this one up here will be the finish contour. So this is kind of taking all the steps out and finishing the floor where is needed of the pocket with that nice ball end mill. Stop. Okay, see we're working our fillet now with that real fine little ball end mill, so we have a nice shallow finish there. And then it's going to blend it right into the walls. And then we're going to go to the boss, take all that step out, where we left that 5/1000. And there's our part. And this is exactly how you can turn it into me. I don't care what view you use or how big it is or if it's top view, fit, anything. That's not important. What's going to matter to me is I'm going to go through all these parameters and all these pages and make sure everything's set correctly. And I'll be able to tell by looking at it when it's finished and when it's running if they're set correctly, and they'll determine where to look. If I see a problem, I'll look in here to find it. So that's all you need. Good luck.